welcome to my channel. So in this video I'm going to cover the solution to this question called encode string with shortest length, and also at the same time I'm going to briefly cover the general steps we should follow in the coding interview. So let's get started. Before we start the real question for today, I would really appreciate that if you can help subscribe the channel because it can help this channel to grow, so thanks in advance. Let's take a look at this question. So given a non-empty string, encode a string such that its encoded length is the shortest. The encoding rule is something like k bracket the encoded string, where the encoded string inside the square bracket is being repeated exactly k times. So note that k will be a positive integer, and if a encoding process does not make the string shorter, then we don't need to encode it. So if there are several solutions, we just need to return any of them. So let's say, for example, 1, we have 3 A's, triple A, then output is triple A, because if we just replace it like a 3 bracket A, then it is the encoded format is going to be with length 4, so it doesn't make the string shorter, thus we just return the original string. Let's say example 2 and 3 similarly, so we can replace the 5 A's with 5 and bracket A, which can make it shorter. And we have like example 4 is something like this. Example 5 is more interesting because it has like a bracket A, B, 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 C, and then there's another bracket outside of it. So let's see the constraints. So the length is between 1 to 150, and S only contains lowercase English letters. So the first step in the coding interview is try to understand the question. If there's anything unclear, clarify with the interviewer, and also think about some edge cases. So until now, I think we pretty much understand what it is asking us to do. Some edge cases, what I can think of is if the length of the input string is smaller than 5, then there's no way for us to have a encoded string to make the original string to be shorter. So I would say the first edge case I would check is if the length is smaller than 5, we just return the original string, and that's it. So the next part is about finding a solution. So this is a pretty difficult question. I thought about the solution and then wrote some code down. So let's go through the solution and then briefly go through this piece of code. So the solution we actually used like a dynamic programming solution. So we defined this DP array, like a 2D array. So the DP array, DP start and end means this one. It means the shortest encoded string. Encoded string for I would say this is let's say input is as from start to end. Encoded format. So DP start end is the shortest encoded format for the substring for S from start to end. So both start and end are inclusive. So how are we going to compute the DP start to end? Actually, what we could do is we just decompose it into a subproblem. So like DP start to end is actually any, let's say it is like the minimum, the shortest within DP start to P plus DP P plus 1 to the end. So P is anywhere, P is between start and minus 1. So that's essentially the DP formula, how we are going to leverage the results from the subproblem to recompose into the solution to the original problem. So it'll be something like that. So let's go through this piece of code to further understand the solution. So essentially, first of all, we are going to check the edge case, and then we are going to define the 2D DP array, which has like the first dimension as the length, second dimension as the length as well. So we are going to iterate through each of the lengths of the substring. Try each of the start point, and then we are going to compute the corresponding DP, the result for the DP, the DP, I would say DP position. So first of all, we try from the length as -1. We try the length as 1, and then until we iterate through all of the lengths, which is the longest length is just the length of the original input string itself. So first of all, we define the start, which is the start here, like on line 8, and and then the end. Then the end is computed from start plus length -1. And we noted it is worth to note that the end is inclusive. So first of all, we get the shortest string. Try to get the shortest string, which is just the substring itself. So if the length is the length of the current substring we are currently looking at, it is smaller than 5, then there's no way for us to actually find the encoded format to make it shorter. So we are just going to have the DP start to end set as the original substring, and then we just continue. Otherwise, if the length is larger or equal to 5, potentially we can have like an encoded format to make the string shorter. So, but we still need to dive into it. So let's see how we do it. So first of all, we will just try to have like like connect shortest with the shortest, and find and try to find like the repeated point. So this one might be a little bit harder for you to understand. So let me give you an example to try to explain this one. So let's say if we have A, B, C, D, E. So this one, actually there's no repeated pattern we could find from it. So what we do is if we connect this one, like if we do shortest plus shortest, it's going to be something like this, and then we just try to find the shortest within this new string starting from the first point. Then it is going to be able to find like the repeated position, which is starting from like the end of the original string plus 1. So so if that is the case, actually it means there's no repeated pattern for us to leverage. So we are just not going to jump into this if branch to make a like an encoded version for it. Otherwise, let's say I give you another example. Let's say we have let's say we have 5 A's. So if we have 5 A's, and then we try to find the repeated position. So when we try to find the repeated position, we find that repeated position return is 1. So this means starting from 1, it is like starting. So starting from 1, that's where we just try we find the original string. And it also means that we can have a repeated pattern with the length as 1. So if we have like a repeated position which is smaller than the length of the original string, then we just find like a repeated pattern which we can leverage to make the string to be shorter. So in this case, first of all, we record down how many of the patterns are repeated, which is computed by shortest length divided by the repeated position. So for this example, for this one, the repeated position is actually 1 when we for this specific example, and the how many number of the repeated patterns appear, it is actually 5, which is the length is 5 and the repeated position is 1. So this one, it gives us like a 5. And then what we do is we have like the left bracket and the closing bracket, and also what we do is we include we include the repeated pattern, I would say, into this left and right bracket. So why do we use DP start to end? So that is because there could be something like say for example 5, there could be something like this. It's like a bracket within bracket, like 2 layer of the bracket. So that's why we use DP, like the DP result, instead of leveraging the substring itself. So this is like the most juicy part for this one, except the DP formula. And after this, what we do is we try to enumerate all of the middle points and see if any of the, if you try to decompose the original problem into subproblem, if there is any way to get us like a shorter encoded string. If it is true, then we're just going to set the shortest to be like a shorter version of the encoded string. And finally, we just set DP start to end as the shortest. And finally, what we are going to return is DP from 0 to the end of the string. So that's essentially the solution to this question. And it is like let's see what is the runtime for it. So the runtime essentially for a 2-layer of the for loop, it has like a n square, and also within each of the, so for each of the like start to end, we need to enumerate all the middle points, so it makes it to be n cubed. But actually what we did is we have like a string manipulation. So for the string manipulation, it makes it a little bit it makes it a bit I would say a bit slower. So in this solution, if we consider like the string manipulation stuff, like we connect the strings, then it is going to be something like because for this one, the operation is going to be kind of like all of n. So we are looking at like n to the power of 4 for this specific solution. So that's pretty much it about the runtime of this solution. And what is next? Okay, so for the coding part, we already explained the piece of code, how it works, but in the real coding interview, care about the correctness, readability, and don't be too slow when doing the coding work. And also the last thing is, don't forget to do some testing. So try to set some test cases to make sure you have good enough test coverage. So other than that, I think we should be good for this question. So if you have any question regarding the code or regarding the solution, whatever, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.